In this section, I'm going to start talking about using Ansible Jinja 2 filters. So once again, we're trying to add to our toolbox of ways we can solve problems using Ansible. And let's look at how we can use Jinja 2 filters to help us. So if I look at this simple playbook that I have here, I have some variables that I'm defining. So var1, var2, a dictionary, a couple of lists, then this device Cisco. Now I get down into my tasks section and I just have a couple of simple debug tasks. The first one takes this dictionary that's up here. So this my underscore dictionary has 3 keys, those 3 values, pipes it through a filter. Now notice we're in our Jinja 2 context. So we have our funny notation where we have quotes, curly brace, so that we can access this dictionary. Then inside this context here, we pipe this through this filter. So this 2 underscore YAML is going to convert this dictionary to be a YAML construct. And then we have this second one, which makes it be nicer looking YAML. So once again, we're in a Jinja 2 context. We're using our pipe character, and then we're using this Jinja 2 filter, these 2 different Jinja 2 filters. Go ahead and execute that filter. We can see here that I get Jinja 2 back. So, or not Jinja 2, I get YAML back. So key, value, key, value, key, value. No quoting of the strings, so we can tell it's Jinja 2 and not JSON. In the format here now, Ansible doesn't actually print out the new lines, but this just comes back as more readable YAML. So if I copy that into Python and I do print on that, we can see we get more readable YAML that comes back there. Now if I look at my second filter, once again I have my variables defined. I come back here and I'm actually using the default filter. So this var3 variable is not defined anywhere. I pipe it through the default, and if this variable is not defined, it's going to print out this string, i.e. it retrieves a default value that we specify. And then there you see the default value. If we went in here and created a var3 and just gave it some string, now it would just print out that string that it has. Moving to more filters. So these filters here are going to concern set operations. So there's a set of set operations available to us. So we have this my list. What does my list have in it? It has all these elements, including a lot of duplicate elements. So if we just wanted the unique set of elements, which in this case is hello world and whatever, we could pipe it through the unique filter. And let's just add a tag here. Say unique. And this one here is just a duplicate of the one beneath it. So let's go ahead, add this tag unique, execute our playbook. I messed something up in my syntax. So I just had the tags keyword put in improperly in the playbook. So here we see our unique items. Now, if I scroll down, we can also do a union of two different sets. So here's my list. I'm doing a union operation with my list 2. So this is going to give us a union of the two sets. So this one has hello world whatever. This has world 377 and Arista. So we should get back hello world whatever 377 and Arista. That's the union of those two set operations. Hello world whatever 377 Arista. Okay, we go down to this next one on line 36. We're going to do an intersection of the two sets. Let me tag this. So what are the common items to the two sets? So the common items are going to be just the world element. So there we see the world element for the common item. And then we have a couple of difference operations. So we have the MyList difference MyList2. So that's going to remove from MyList any elements that are in MyList2. If we go up here, that's going to remove from this MyList treated as a set. And remember, MyList treated as a set is going to remove any duplicates. So it's just going to be these three elements. And then it's going to remove this world element. So all we're going to get back is hello and whatever. So we have these bunch of set operations that we can use using these Jinja 2 filters. Now this last one is a symmetric difference. This is what are the elements that are unique to each list. So the non-overlapping elements. So hello world whatever in this one, world 377 and Arista. So hello and whatever are unique. 377 and Arista are unique. This world element is in both. So the completely unique items are hello, whatever, 377, 377, and Arista. And there we see that. So those are the set operations that we can accomplish via filter. Now, what about combining dictionaries? So I have my dictionary above here, which has key 1, key 2, key 3. Now, notice here, I'm piping this through the combine filter, and then what's going to happen is it's going to actually add these elements to the dictionary. So at the end of this, we're going to have key 1, key 2, key 3, and also key 7, key 8 in the dictionary. Key 1, key 2, key 3, key 7, and key 8. Now this last one's a little bit of a funny syntax. So here it's telling you what to extract. You define the keys you want to extract, and I'm defining those just straight in a list. Then I'm piping it through this map filter And notice I'm using the extract argument to the map filter. And notice that I'm operating on my dictionary. So back in my dictionary, I'm going to extract key 1 and key 2 and the corresponding values from that dictionary. And then I'm going to construct a list from that. So at the end of this, I'm going to have a list that is the values corresponding to key 1 and key 2. That one's syntax is definitely peculiar. So ZZZ and YYY, those are the values corresponding to key 1 and key 2. And the reason I had to do this second pipe through the list, i.e. this second Jinja 2 filter, is by default it returns a generator. So we have to tell it to extract all the items, i.e. create a list from that generator. Alright, some more filters that we have available to us. We have a ternary filter. So if this condition is true, you're going to get answer 1, which in this case it is true. Device does equal Cisco. If this answer is false, you're going to get answer 2. Similarly, you go down here and you can see we're casting something as a Boolean. So it basically casts this string and returns a Boolean. And then notice down here, we actually are doing a regex replace. So we have some big string, we pipe it through this regex replace operation. This is a regular expression. Notice I had to backslash escape the backslash. So here's a backslash s plus for white space. Here's the value I'm going to replace it with. Whatever I saved in parentheses. So basically starting at the big word all the way to the end of the line. I'm going to replace it here, and then I'm going to add on this space test onto the end. So some more potentially useful operations. The ternary operator, the Boolean cast operator, and then this regex replace filter. Now let's start looking at a more real-life example. So here I have a couple of variables defined, a credentials for use with Ansible core modules, and a credentials underscore napalm for use with napalm iOS modules. Now here I call my napalm get fax. So I call napalm get fax module. I provide the provider, which is defined here, and I use the ARP table filter. Now notice here I get down and I call this napalm ARP table variable, which is the output variable that comes back from here. I pipe it through the map attribute. And let's just look at what we get back here. Call this napalm only. I'm going to rerun that with the verbose output. So here's the output I get back for PyNet Router 1. I get a list where each of the elements of the list is this dictionary with these key value pairs. And notice one of these keys in each one of these list elements is the IP key. Now say I only wanted to make a list that just had all the values in the ARP table, meaning all the IPs that were in the ARP table. So this IP, this IP, this IP all the way to the very last IP. That's what I'm doing here with this map. So I'm piping it through the map. I'm providing the attribute equals IP. So the attribute equals IP means it's going to extract the IP key from that list. So extract all the IPs, and then at the end I have to cast it through this list filter because it comes back as a generator. Now here I just do the same exact thing as I did above. Oh, no, I don't actually. Let me add this tag here so you can see the behavior that I'm referring to there. So here you see I get back for both PyNet Router 1 and PyNet Router 2 because we're operating on the Cisco group. Here's the list of IPs for PyNet Router 1, and here's the list of IPs for PyNet Router 2. So you see we've modified the variable that we got back here, and we created a new variable. Well, we didn't actually create a variable, but we could have using setFact. We just printed this new variable, in this case, to the screen. So we morphed it from this Napalm data structure, used the attribute IP to create this new list from that. Now let's take that another step. Let's go ahead and create a new dictionary. So I'm going to name this my_dictionary. And notice there is no my_dictionary defined. I'm going to default my dictionary to be a blank dictionary. I am then going to loop over all the items in this ARP table. So I'm going to do a for loop. Each time through, I'm going to get one of these dictionaries back. So each time through my for loop, I'm going to get one of these dictionaries back. I am then going to use that combine filter that I showed you earlier. So I'm going to start adding new items to this what's originally blank dictionary. Each time through, I'm going to add the IP address and corresponding MAC value. So you know how previously we used this external Jinja 2 filter in a file to modify a data structure to make a new dictionary that we wanted, where the dictionary corresponded to the IP being the key and the corresponding MAC address being the value. We're doing that exact same thing here, but we're doing it all through this combine filter operation coupled with a for loop. And then here, we're just going to print it out at the end. And I'm going to add tags to this. Make this be called combine. Go ahead and operate on that. Oh, and I actually need to gather my output. So with tags, you can have multiple tags. And we'll call that combine also. That was complaining because it didn't have the napalm output. Now notice we have a new data structure. We've called it my_dictionary. Keys are the IP addresses. The corresponding values are the MAC addresses. Okay, so at a high level with these Jinja 2 filters, we're trying to add something into our toolbox that enables us to do certain useful operations in Ansible. So One of those operations is to morph a data structure from being in one form to another, but there's also a lot of potentially other useful operations, and there's a pretty large set of Jinja 2 filters that are available to you.